Hello everyone. Today I'm going to show you how to do the wet map. We have a basic idea, but I got two ways to do this. First, let me show you this basic liquid. Okay, let's get started. I have the houdini, so I got the file cache. Then I go to rugby laboratory, and this one I have this laboratory. I got the color, subdivide, then I put the library. You can see the color. We have the color CD, so it's black. Another way we object merge this fluid. Then we delete attributes. We didn't need any attributes. Maybe we can keep away, but it's okay here. Then I give it a color. Is color 1.5.2.25. Okay, then we have a solver. The basic idea is transfer attribute transfer. We transfer the color. It's really simple. Let's transfer the color. CD. Let's get rid of the texture. Then let's see how it works. Let's show the particle. This distance threshold is really important. So we give half of the blend multiply 0.5. This distance threshold, you can see we can thresh the transfer color, how much it gets transferred. So maybe 0.5. See, when the particle hits the laboratory, then it have the particle's color. But if we just use transfer, it doesn't keep the color continue on the laboratory. So we have to make use the solver. So we go into the solver. This previous frame is the fluid. Is the laboratory. Then the second input is the fluid. And then attribute transfer, the same attribute transfer. See, I can copy here, paste, make it the same. 5. After this, I give the fade because every CD will multiply 95. It means one frame it get fade of 5% of the color remain of the rubbery. So it looks like this. Let me show you this. Check. See, the color will fade away after the particle run through this laboratory. See, this region we add attribute angle CD multiply this value. And after this, I can blur attribute blur CD, so make it make it not harsh. Make it not harsh, just like this. You can see it's quite nice. So this basic attribute transfer. This and why I do have this attribute wrangle because I add this wet, maybe wetness. It doesn't matter. So maybe add wet equal CDR mod plus CDG multiply dampness 0.5 and CD1 minus wet. So we can get what's the result. You can see here. This area is quite damp after particle flow. See, like this. Another way to do this wetmap, we use wetness attribute. This is another way. Let me show you. For the laboratory, we create a wetness attribute, make it equal 0. Then we for the particles, we create wetness, make it 1. Then we transfer this attribute in the solver. Let's check inside. Here we one input is the first input. First input is the laboratory, and second input is the particles. So we got the first input, then we have the previous frame. So we attribute copy, make all the wetness will update with the frame rate. When you admission, it will update. The particles we get in, so it's the second input. Also, we have a color CD. Then we use attribute warp here. We didn't use attribute transfer because attribute transfer we didn't have much control here. Just the points, the CD, just the distance record. We have the attributes will be, we can use the ramp to control the color and control the wetness. Also, we can use open PC open. We can get the search videos when we have a lot of particles. We get more accurate and more control. So let's see. First, we have the PC open. PC open. We read from the second input. It means the particles. We read the second input, the particles, then connect the PC open. We get this PC field. We can filter in P, so we can get the particles position in the attribute warp. Then we use this distance and compare the distance to the original regulatory distance. Then we can hook this, go the CD, we can check how it looks. Let's go, play. We have to reset simulation. See, we got this, and this point radius and also number of points certain we can control here, like radius, also the mask points here. Then you can get here, you can set control. After this, we use the ramp parameter to control the color. Ramp parameter. First, we filter in this distance. We use the maximum. Use the radius to control the maximum. Then we ramp together, get this. Let's check the name because we already have the ramp. So let's check, set the name. Let's see how it looks. Okay, we forgot to set the ramp. So the ramp should be like this. Let's check. See, the drop tree is getting black when the particle hits its geometry. Actually, we don't want black. We want render the wet map. We want it become wet, so we can start switch this. Also, you can control here. See, the ramp is really good. You can control. You can control here. After the CD, we get the result, but we actually want the wetness to transfer, not the CD. So let's see how we can get this through. This is a new setup we did, and it's really simple. Let's see how it works. First, we use the PC open to PC view to get the position of the points. Then we compare the distance with the original rupture. Then we get the distance of this position. Then we fit this distance. Why we use the radius? Because radius means how the particles, how much is the distance near the rupture. So we use this to maximum the maximum value. Then we get 0 to the maximum. Then we filter in. We get 1 0 1. Then so we get the CD color. But as we know, we can see here at the beginning, the particles are not hit the rupture. Also, after a few frames, the particle not are all leaving the rupture. So we have to check when it happens. So when the wet map happens, when this transfer attribute happens, so we use a PC num font because we already have the PC open, like we have the PC open, so we need the PC open font. What does this mean? Let's it's refer. You can check the help if you want, but it's actually refer some value, like when the particle hits the arbitrary geometry, it will return some integer value, like how many points in this radius get hit the arbitrary. Let's band out this value. You can see what I mean, like number point number. Let's get out. Receive some frames. Okay, let's just check. Point number. Let's check the name. See, and some because where is all go 10. Let's see some other points. It's go 10 or not? Why is all go 10? Because we set the PC font. PC font here is the maximum points. Maximum points it's 10. You can see it's 10. Let's set 50. Then we reduce the point. Reduce the search radius. Let's same again. When you reduce the search radius, you can see the point number. I should call point amount, not point number. See, we have some got 1, got 49, like this. So it gets our value. When you hit the Nautilus near this radius and near this at the maximum point, you have the value. So we got this, but we need we need compare. When it's greater than 1, then we can get something. If we didn't greater 1, it means 0. 0 means no particle hit the Nautilus, hit the rotary point. So we get this 0 and 1. Let's see here. See, 0 and 1 is all 0 now. So all 0 and 1. After this, we go switch. Switch means switch means if it's 0, it's this condition is worked. It's return the it's 0 is return the first input. So first input is 0, it's okay. If it doesn't work, it return the ramp. Yeah. Then we have the color. We have the color. Then we can use the witness. We can band import witness Then we can maximum the witness with this. Maybe go first here and then second here. Then it doesn't matter when we band export the witness. Yeah, that's the story. Then we add the same witness multiply. It's not CD because we don't care about CD now. We care about the witness. I'm not sure you guys follow me through this or not, but let's double solve the network. It's quite simple. Just PC open to read. Delete all this. The new setup. PC open, read this, read this PC found. If we found points, we compare with 0. It's great 0. It's return the 0 result, the first input. If we don't, if it's great 0, it's 1, so it returns ramp. Then we ban the witness because we already transferred the witness here. So every frame it updates our witness. Then we maximum this witness, get the witness out. Yeah, that's all. After the solver, let's check the witness value. Let's reset. Witness. See, we have a value. That means this witness will get transferred. How to show this? Let's go take a witness. You can see, yeah, this is the color. It's quite supper. So we need attribute blur the witness. So blur 1 or 2 or 3. It depends on what you need. So now we have the more control here. Okay, control the control the ramp. Also, we can control the how many points. It depends how large your scene. So it's search radius, also the maximum points. It depends how large your scene because it's a small, so we need this value is okay. But if your scene is so huge, it's maybe 1 or 0.1 or so. So it depends. After this, we got this. So if we saw this, if we saw the witness map beautifully, you have to check here and here. I check the witness. You have to use the maximum, then ramp attribute maximum. Let's see how this method get the result looks like. This is the first result. You already saw this. Beautiful, right? And this second one, similar. Similar. Then fade away. See, similar fade away result. See, color is beautiful. Yeah, that's all. Thank you everyone. Hope you enjoy this video.